All righty. Good afternoon, everyone, and welcome to another Thursday edition of Topple live stream, where we'll be today discussing it's a bit of a mixed thing of the normal office hours that are going to be hosting, just going over answering questions and doing some work session type things, as well as just we're going to merge into the live stream this afternoon and kind of make it one big thing. I guess I'll introduce myself. I'm James. I'm the Chief Technology Officer and one of the co-founders over here at Topple. And I'm joined here by Edmundo. Do you want to go ahead and introduce yourself, Edmundo? And I don't. This is the first time you're joining us, so maybe let everyone know who you are and what you do at Topple.
Yes, hello, I'm Edmundo. I'm a blockchain engineer here at Topple. I'm working right now with double contracts and also trying to contribute with the definition of Quivr.
Nice. Thanks, Sarah. So today we want to spend a little bit of time going over a few different things. Primarily the construction and discussion on this extended UTXO smart contract system that we're developing over here at Topple. So there's a lot of really interesting things with using extended UTXO smart contracts that are very different than the paradigm of like EVM contracts. And so it constructing and doing computation in that model is a very novel thing. There's not a lot of mind share that has been, or design experience that has really been put into the space as far as we are aware. So that's what we're going to be working on and discussing. And feel free if there's any questions, feel free to drop in the chat or reach out to us on any of our other social media channels, or you can also find all of our code on GitHub. As everything we do is open source over at Topple, and that is for the betterment of, we've got to make sure that it's robust and safe and secure and useful. So let's go ahead. I'm going to share my screen. There we go. Let's go ahead and I'm going to try this version. Oh, wait, it's not really like the most. Maybe if I don't know. No, it's not. It's actually really no better if I do this. Is it? Well, we're going with that. So I get for having this weird aspect ratio on my my monitor. It's because they're too old. So Edmundo, we've been discussing lately, how to write a DSL in Scala to do this, to enable this extended UTXO smart contract system. So I'm kind of curious, I have never really studied languages or anything. Can maybe this sort of description, this description of how to do a design, how to actually design a DSL in a very practical way, is kind of where I get a lot of my thoughts around, or practical means of things I want to do. But I'm very curious, from a maybe for everyone, can you describe for us or give us maybe a more general definition of what it means to what a DSL is, or why do we talk about DSLs, or why do you think we talk about DSLs with in the context of blockchains?
Yeah, so in a very general way, DSL or domain-specific languages are, as opposed to general languages like Java, Scala, or whatever language, are languages that are specialized in a domain. So the target user is not a programmer, as in a general language, but some domain expert. For example, for the blockchain, that would be someone who is writing, a contract, in this case with Quivr, that governs how certain transactions or certain transaction logs, for example, if the transaction can be done or cannot be done depending on certain conditions. So that's what you want to express. And with a general language, the approach would be to define functions and data structures and make them work together and define some kind of API, but still having the full power of the language behind. In a DSL, we try to constrain that a little bit so that the expert, the domain expert, the expert in blockchain contracts, for example, that doesn't need to know the specifics of how Java works or how JavaScript works or whatever language we choose. He can focus on the domain he's working on, in this case, writing a contract. So we want to provide him or her with a language that one can use it, and that it's ergonomic for him. So he or she can use it very easily and it's intuitive for him and it behaves as one might expect. So that would be the advantage of using a DSL. So it constrains the domain. Normally, you want something less powerful than a general language, but it introduces, for example, the terms and the operations that the domain uses, and it leaves out the operations that are not necessary for that domain. So that would be the main, in a very general way. In our case, in Quiver, we want is a domain-specific language to describe, well, it can be transaction logs or contracts on, yes, on how to spend a specific box in the blockchain. So the contract would say which rules we have to, or what do we need to fulfill in order to spend some asset that is stored in a UTXO, for example. Yes, so that would be it, very, very generally. So you are muted. I cannot hear you.
I'm so sorry. I'm sitting here talking the whole time. I didn't realize I was muted. uh, you think after like 2 years or almost, yeah. Anyway, okay. So I'm sorry. Yeah, and specifically in Quiver, I think this is a really great way to talk about like what a like a generic DSL is, and like how like I would hope this is like maybe a really high level. I hope this is a reasonable generalization or summary of what you were describing. And exactly like you said, that the DSL itself or Quiver itself is a DSL, but it's just a DSL with a particular type of construction and with a particular domain in mind. And so the one thing I did want to ask though is like, it's always really murky, right? Like, what is where do you think the line would draw between when it is a DSL to when it becomes a language, right? Like there's much more of a spectrum than like a well-defined line in at least in my experience. I'm curious if you would agree with that.
Yes, I have an interesting example would be the DAMO DSL, the Digital Assets Markup Language.
Mm-hmm.
And it's a domain-specific language in the way that it tries to model some specific real-world interaction, which is real-world contracts, the kind of contracts you would make with the presence of a lawyer, you see?
Right.
So there are signatories, observers, maintainers, all of those kind of entities or attributes that would appear in a real world contract. But somehow it's still Turing complete. So you could, in theory, use it to program anything that a machine can program. So from that, we can start saying that Turing completeness is irrelevant for being a DSL or not. I would say that the main attribute should be that it's really oriented towards a domain. So there is a it models a concrete domain, and it offers the users a way to express their domain in the language in a relatively easy way and intuitive for them, not for not for a common program, but for the domain expert, the subject matter expert. They need to feel that it's intuitive. They need to express the thing that they usually express in their usual tools. They need to be able to express this using the domain specific language.
Okay, interesting. That reasonable? I'd say should try or should strive. I really mean. I'm sorry. Say again.
Yes, I think we can define them in the terms of the user. So domain expert should feel comfortable using that language. So I guess if that requirement is not fulfilled, maybe you have a DSL, but not the quality is not good. Of course, how to measure that is another question. But yes, domain users the domain experts need to feel comfortable expressing their domain in that language. It has to be natural for them.
What was that? The wording's a little weird, but I think it's reasonable. Okay, I'll
Yes,
work on the wording.
it looks.
Okay, cool. I'm sorry.
Looks
I'm writing them down because I'm realizing this is just. I might as well just save these as notes for putting in some of the specifications. So thank you for helping me generate a copy. um, awesome. So yeah, that's a really good point about the DAML as well, because the actual like capabilities or like what is needed to achieve Turing completeness is actually like pretty minimal, right? Like you can achieve Turing completeness with just binary, like ones and zeros, but like it takes a really big machine to be able to do anything, right? So like the simpler your system is, in general, the less expressive it is, unless you introduce a lot of operations, right? If you only have a couple of states, maybe that's like what I'm trying to say is like, if you only have two states, like 0 and 1, then I have to think of really elaborate constructions of those states to then represent like, expressiveness. Right? But if I can make generic states, if I can define generic states, like I might be able to in a DSL, and I have a way to define the generic state by like maybe another language, general language like Python or Scala or Java, then I can express my states and then express like because I have such well-defined states, I can then define really well-defined transitions between those states, such that I can have a really tightly or well-defined and constrained like finite state machine of I have my states, and then from this state I can go to a couple of transitions, and from those transitions I go to another state, and then it's a complete enclosed system. I would think that that's the sort of system I would want in a DSL, like a finite state machine.
Yes. Yes.
Nice.
That
Awesome.
would be desirable.
Cool. So, really related to this, early on when we were first exploring, Scala, or not exploring Scala, but like, I guess when I was really first getting introduced to the functional world of Scala, right? When I was first taught about type classes and, the classic monolith thing. And so it was one of the things that when you're learning that, like, how to lean on the compiler in Scala and how to get comfortable with implicits, it's been very popular recently for this idea of tagless final style. And so while we were trying to learn this tagless final style, there was a really timely article by this gentleman, Daniel, and I'm not even gonna rock the JPM. I don't. Daniel is an amazing teacher. But he had this article that came out about explaining kind of at a really like nuts and bolts level what tagless final is and how to describe it. It actually pertains really well to this idea of defining a DSL.
Yes, that's exactly what it is.
Yeah. So I don't. I'm just gonna maybe go through that really quickly. I will let everyone know, like, there's a companion video to this as well. In the how can I do this? I can do like this, and I can do it in this. I can do that, and that, and I can also do that, and I think this. Oh no! Oh, don't play the video though. Oh, that's the starting screen. Never mind. And this, and I think I can add a banner like that. Hey. So if you're interested, highly encourage to watch the video if you're interested in Scala, just good instructional videos, tagless final in general. Like I said, really well done. But we'll go through the blog form for now. This is also available at this. Save, please. Here we go. And I will put that in the chat as well for anyone who's so interested. But yeah, so really, like I said, really briefly, we'll kind of stream through the highlights of the blog post. So this tagless final style, and here's the video as well. There's this original paper, which is, oddly enough, was a professor from Rice. So it's really funny how Rice keeps popping up in all of our the work all the time. But yeah, so tagless final, like the way he introduces it, it's a super, like I said, it's super effective. He just talks about it as being a solution to the expression problem, and as from what I remember that's also the way it's introduced in the paper as well. But yeah, I, having not been super familiar with the expression problem, I mean, this is basically my understanding. But would you, this feels like the primary way to describe the expression problem? But would you think, is this like a reasonable description, or do you think would you have anything to add, Edmundo?
Just let me reread. I remember the expression problem. I have read some papers on that, but I don't have it in my mind right now. But he says, if we are given an expression computing a value, we would like to be able to evaluate it and return of the right type. Okay, yeah, well, that's a very, very, very general way of saying it.
Interesting.
Yes.
Interesting. I'm very curious because I mean this like very generic description of it makes kind of sense to, or I think it makes sense to me. So I'm very curious.
I think here, and I'm not sure because it maybe not the same expression problem I'm thinking about, but from what I see here, it's basically what we think about in functional programming, we try to avoid the side effects until the end.
Mm-hmm.
So basically, instead of like in imperative programming, like we would be doing the computation as we go,
Mm-hmm.
like instead in functional programming, what we are doing is like we are combining values that represent the actual computation. So and at the end, so we are basically building our program. So at the end, we
Right.
have a data structure that represents the program that will compute something.
Mm-hmm.
So, and what we want to do is take that data structure, that whatever it is, evaluate it, and return the proper value of the light type for that expression. And well, and that's exactly um, what Tackle's final helps us to do. We define a kind of algebra,
Mm-hmm.
and that algebra represents our program. And then we have an interpreter that goes through it and evaluates.
Yeah. Yeah, and so I think I really like the way he. Okay, so yeah, I agree. I think this is a pretty. Okay, I'm glad to know that this is a reasonable, or at least I think it still remains a reasonable way to describe it. Um, but yeah, to like I guess really kind of bring this home. This might be a very if you don't understand for like viewers at home or anyone else like later, we can concretize this a little bit by just thinking about this expression. Intuitively, we as humans are like if you understand or if you've ever looked at like Boolean circuits, you could probably evaluate this function, right? You don't need to. But if I gave this to a 5-year-old, right, a 5-year-old doesn't understand the algebra, doesn't know what Boolean algebra is necessarily, right? Whereas I look at this and I like intuitively know that this symbol means an and this symbol means an or, because I also know what the number 2 looks like and the number 3 looks like, because we have these like shared grammars and this shared like knowledge, right? And I also know what the word true and false. Like I know that those are generally meant when things have it's a 2-value system and it's only true or false. Like the type, I implicitly I can just look at this and I know the grammar and I basically know the semantics such that I could solve this, right? We as humans could do that,
Mhm.
but a computer can't. A computer would, I mean, we program it like this. I guess we could, but like, what if? I'm trying to think of a reasonable example. Like, what if we had it? What's a 2-state system? Like I don't know. I'm trying to think of some silly example that, because you can do computation with like physical systems, right? I could have a physical bit. I mean, bits really are kind of just they're electrical voltages, so they're kind of physical in a sense. Um, anyway, I'm sorry. I'm getting it. Don't worry about that part. And then this is just like another way to write this thing. Is there would you call this the infix form? Is that the right term for this? Or the infix?
And yes, that could be an infix form. I think that
What?
assuming that the other one would be the postfix. Yes, for the operators. I mean, yes, but yes, but how can no
No.
the first like true and false or true,
Uh huh.
like well, it's
I guess
like a
it is kind of
string.
actually.
It's a string. You see, just a string, and
Uh
for a
huh.
computer to understand that, it needs to translate it to a data structure. And what he does here is it transforms it to this or and this is called the abstract syntax tree, the AST.
Yeah. So yeah, we can exactly. So like this. So this or corresponds to this or, and then we have
Yes.
a true over here on this side. Then we have a
Hmm.
and over here on this side,
Yes.
which is actually kind of now that that's funny that when you mentioned that, because I didn't think about it the first time. Uh,
Yes.
it's
That's a
it's actually a
notation,
little
I would call
ridiculous to
that.
me to say that, because if I would say if I do it left to right, is it the same? True and false would be false, and then or true, so that would return true. But when I read it this way, I would get, oh, it's gonna be, it doesn't matter what this is because it's true. So never mind.
Mm-hmm.
It doesn't matter the parentheses because yeah, never mind. I think you said that, and it just took me a second to get there. My bad. Okay. Anyway, what I really love about this, like his way to describe it, is because he actually really walks it through really simply. Because you know, we could define this like expression thing to just share. So these are like an enum, right? That's how I think of this. Is right. I'm just like,
Yes.
I'm providing a case class B that wraps some known type, and then I'm putting it into a like an abstract data type or an algebraic data type almost, where it can interact with other things of its type, right?
Yes, that's not almost an algebraic data type. That's exactly an algebraic data type.
Oh, okay. I didn't know if that was because the way we always write them is like a sealed abstract class. I didn't know if that was like a rigorous definition or just like
it is an ADT.
It is ADT. Okay, so
it's
just like
another way to write it.
Just this, like an enumeration, is just that all that is an ADT.
Oh, an ADT is a set of signatures, like, and those are the signatures. You see.
What do you mean by
signatures? Signature is like, for example, that it says that the OR takes a left expression and a right expression.
Oh, you mean like type
signature? That's a signature. Yes, that's the type signature.
Or function signature. Okay, I see. I just didn't understand what you meant by signature.
Yes, that's what we use a lot in Quivr too.
Okay, so then yeah, and then the real fun comes when you want to write your eval function, right? And I don't know, is there? I feel like I run into this problem a lot when I'm trying to explain these sorts of like computational systems, because when I see this in Scala, my mind, like, because expression here, like expr is of type expr, right? But expr, you know, has inner thing, like this stuff is in the parentheses. I have to kind of like, if I'm given an expr, I have to like open the expr. I have to like examine it to like be able to manipulate the instance, to like do something with it. Does that make sense?
Yes, but you know what we are doing here, if we can look this from a set theoretical point of view, and we can say that expr is a set that contains B or and not. And we can define them using like sets. So B with a Boolean is an element of expr. And if we have or with a left expression and a right expression, is also an element of expr.
Yep.
So basically we are defining a recursive set over there. And it's another way of saying it.
Yep. And then where we can do this here because I mean we have a single type, right? We have one like primitive data type, and we return that same primitive data type. So we kind of like I think of that. This is I'm sorry, say again.
No, nothing. That's the return type of the evaluation.
I'm sorry, I didn't hear you said. It's the type of the evaluation.
No, the return type of the evaluation.
Oh right, yeah, exactly. Yes. My primitive type, or the way I think of this is like my only primitive. If I have one primitive type, and my return is the same primitive type, then yeah, I don't. As long as I can do as long as all of my other operations like know how to resolve on that single primitive type, then yeah, I could define as many operations as I want, right? Without ever having to make this more complicated. Where this gets more complicated is whenever I want to define an expression or like an algebraic data type where I have more than one like primitive data type, which is what we do like here. So what if I want to not just have Booleans? What if I want to add integers as another like base data type? So now like our algebra would have Booleans and integers. And then then the problem gets really kind of gnarly, right? Because you can also at the same time define an expression.
The operation, yes.
Yeah, but this would be like this is at least a way to think about trying to do to rewrite the eval function, but it's pretty nasty, right?
Yes, it's using instance of.
Yeah.
Yes, it's not.
For anyone in the audience or anyone in
Mhm.
the future, like just don't this is like code smell. This is just is one of those wisdom things. Like, just try to avoid ever writing this. Try to avoid ever interacting with code that uses it, unless you really know what you're doing, right? If you know what you're doing, it's fine. If you have to do it, you have to do it. But the beauty of Scala is it lets you do a lot of things really easily, and the terror of Scala is it lets you do a lot of things really easily.
Exactly. With great power comes great responsibility.
There you go. Perfect. I love it. Okay, but yeah, so I really love this because as soon as I saw this, I was like, God, it just even looking at this expression makes me nervous. It's just like I get this weird like code like feeling in my gut, my chest. I guess. I don't know. But so then yeah, and then this actually made I love the first time I read this. It's really surprised me how often this idea of tagging comes up. Like whenever we talk about like computation or not computation or like nesting, like outsourcing computation, like people loved like colored coins. Colored coins are just a way of tag, right? Like it's such a natural thing to think about, like when I need to distinguish within a domain to tag, but or to like do something akin to tagging that feels like a very like low hanging solution, if that makes sense, or like obvious solution. I'm curious if you like, does it make sense what I mean by that, or would you agree or think that, or do you have any other ideas or examples?
I'm really so used to the tackless final pattern that I never have thought of this. So, but yes, it is. Yeah, basically, we are embedding the type system. Well, this could work in early Java that didn't have this kind of stuff. You could use this if you don't have the type system, the Scala type system.
Oh, really? Wow. Yeah, I don't know. I really, it's, yeah, it's kind of, yeah. I'm sorry. The way I think about this is, for some reason, when I read this, it feels to me like the kind of the worst of both worlds. Like the initial embedding feels like the worst of both worlds, because you've introduced the complexity of an additional type parameter, but you've also introduced this like attempt to resolve that issue that actually brings a much worse, I think, much worse opinion. Because if you start nesting these things, if you start like building out compositions of systems where you're using this tagging, my intuition tells me what you'd end up doing is you'd end up carrying tags, like when you're like 3 or 4 layers deep, you'd have a tag, or you'd have to carry all the tags from all the upper layers, like around you.
Because this doesn't even count if you have subtyping, for example. What would that mean? So,
yeah, right. Yeah, exactly.
How would you write that?
Yeah. How would you write that at all? Like, it would be silly it would seem really silly to try to do it in this fashion. But I'm just imagining if you did, you would just end up with like this whole array of tags that you'd have to carry around with you, and it just feels like hell at that point. So yeah, I don't know. It's weird. Like it feels a little better, and I understand. Like it's good to go from here, like from this thing of like, okay, well, we'll just like tag with these strings, and then you go to like the tagless like.
What I like here is that we have the origin of the name because it's tagless now.
Wait, I'm sorry. Say your
previously the previous attempt we have a tag, and now we are tagless.
Oh yeah right. But this is only tagless initial, right?
Yes.
Because and I don't know. What do you? I mean, I guess he kind of gives away the answer, but is higher kinded types and strict typing, would those be the only thing needed? Only like supported things needed to be able to structure code in this style?
That's a good question.
I guess you need something to be like, you need to be able to do something like extensions like this.
Yes, but what you need is the capacity to do ADTs, in fact, because
Yeah.
here we are using this as an ADT.
Yeah,
So
that's
I'm
good.
not sure because I don't think Haskell, and this pattern was initiated in Haskell. I don't think Haskell has extents. I'm not an expert in Haskell. Maybe it has. Haskell experts are hating me right now. But yes, no. My feeling is that you don't need the extents. You really need the capacity to define ADTs.
Okay. Yeah. Yeah. I mean, I could see that. But yeah, I also what I love about this is like once you, I remember when I'm sure I've told this story before, but like the in LabVIEW, like global, like implicits are the enemy. You don't want globals. You don't like global variables. Normally, global variables are implicits, and in fact, they do make coding very difficult sometimes. But man, when you can have the invariant that you only ever have one type of a certain, one instance of a certain type in scope, dang, is it powerful and is useful. So I just love like how elegant it is to kind of lean on the compiler and just like have like like I don't know. I don't know if it's correct to say this, but the compiler feels like correct by construction, or it's like we're approximating correct by construction. I know it's
Yes,
not because it can't
that's the
get you every
goal.
error. There's still runtime issues, so I don't think it's correct to say it's correct by construction. I don't think it's accurate. I'm sorry, but it feels like you're at least you're getting rid of some of the errors that you catch. Which
Yes, I agree completely.
yeah, I wish we would teach. What was your first programming language that you learned?
I learned the first one was C. Was then I learned Perl.
Perl.
And and then in college in computer science 101 they taught you doctor scheme, which is a variant of Lisp, and I think it was meant to throw off everybody who thought they knew how to program, and then they threw you a Lisp, and it was very functional programming.
Interesting.
Very pure.
I kind of how difficult is, I've never learned Lisp. I mean, Scala was like the first, I think, real programming language I ever like really I learned I learned MATLAB. It was like how I taught myself how to program, and then LabVIEW, and then JavaScript, and then Scala. And when I got to Scala, I was like, this is the epitome of programming languages right here. Everything else has been terrible to this point. Sorry. Sorry about that. Yeah, so literally you can't even write. I couldn't put or a bool into the sum because there is no which for folks, if you're not super used to like Scala syntax, the constraint isn't being assigned here. I think when I was talking to someone earlier about this, and I think maybe it was a little confusing that they were expecting the constraint to be like, because in these other ones you can see the constraints are kind of enforced at call time,
Exactly.
Right? They're on the call side. Like whenever you're writing this function, the person writing the eval function has to think about handling the errors. Right? Whereas in this version, the person defining the domain gets to define the constraints and how to and maybe not how to handle them necessarily, but at least they define what is and isn't right, and the so that the on the caller side you don't have to worry about it. And this is like I feel like it's pretty general. Now that like even as I said that feels like that's a pattern we repeat a lot in functional programming, like moving stuff from the caller side to the like definition side. I don't know if that's is there a certain term for that? We might have some. I know there's some folks that might have wanted to join in. So if you guys would like to, feel free to just hop in. I'm sorry, my bad. I don't know. Howdy, Sean.
Hey, y'all.
Howdy.
How's it going?
Hi, everybody.
Howdy. Hey, Hans. Hi. Thank you guys for joining on my, office hours turns tutorial on or the working session on Quivr. I do eventually want to go over to Quivr. Look, can we call this Quivr 4S? Can that be the playground? Can that be the reference, the Scala implementation for Quivr 4S? But anyway, I'll try and get over there in a second. Okay, yeah. So removing tags. So we got rid of the tags. Great, beautiful, wonderful, amazing, but not good enough because we still have to unwrap. We still are doing this unwrapping thing. Like I don't know. I feel like Sean, we've talked about this, or I think we've mentioned this before, but pattern matching. Like on the compile, like I mentioned this to Hans earlier, and as I was saying, I was like, I don't actually know if this is the case, but like I know unboxing is like an expensive operation in the JVM, right? Is pattern matching like pattern matching does an unboxing versus mapping, which somehow doesn't do the unboxing, or is like it optimizes when the unboxing has to happen? Is that the right way to like phrase what happens?
I think that it depends on how complicated the match statement is. The compiler makes different decisions.
I see.
If it's just matching on types, then it's literally recompiling it into if like expression is instance of B, and then like unwrap it. But then like for other cases, it uses like a lookup table, and then other cases, I don't know. There are different like ways it handles match statements depending on the complexity.
Interesting. That's funny. I didn't know that Scala was run by a lawyer. Like the compilers, it's been written by lawyers. Okay. Well. So yeah. The way I think about this though is that I view it as like you're staying outside of the domain. Like I don't know. I picture myself as like when I call this function, I have to assume I'm in some domain, right? I have to be like quite literally, like if I go and I try to run this thing if I try to compile it in Scala, I have to put it in a main method, right? Or like in an object at least, and then compile it. So I have to be in the domain of that object, or at least that's, like I said, the way I think about it. And then kind of if I stay in that domain and I want to like define operations or like service logic, then one way to do it is to like stay in the domain I'm in and then kind of like open up the response that I get, or the response that I'm given, the argument that I'm given, this expert of A, and then like pull out the A, and then like the way I think of it is like mapping it into the domain that because here you're kind of doing that mapping. You're saying that I know how to, given this value internally, or given like this thing that has this type of value internally, I know how to map that thing into my domain, right? I don't know. I'm also, I'm more saying, when I say right, I'm more saying, do you guys agree with this characterization, or do you think it's a mischaracterization? This like idea of like reaching in or like mapping it into the caller domain.
When I discussed this with you earlier, it was my impression that you were telling me that this is the right way for it to be. So I just took that as gospel and I just believed it.
I mean, it was, as I was saying it, I was like, I gotta actually check to make sure that I'm not just pilfering, like pushing lies.
Well, I totally bought into it. So I'll just repeat that even if that's untrue.
Okay. Well, if we do assume that that's the way to think about it, it works for me, because then you can, the way I think about what the tagless final thing does, or like the tagless final idea, is that, hey silly, why are you like, you can actually make it a little easier on yourself if you just assume that your exit domain is like, what? Why don't you don't define your service logic? Don't define the like how these things run by first opening up this thing and then mapping the values into your domain and then having to remap into the other domain again, right? Like that's what this is kind of doing in a sense. Like here it's not necessarily pulling it into your domain and then like mapping it out. It's here, it hasn't fully unwrapped the original domain yet, because a left has those things in it. Left is the label. So I'm sorry, it's an OR. So the OR has this expert boolean, so it has to continue to unwrap. But once it finally does, it hits that terminal, and it's that boolean or an int, and it knows how to map the boolean or int into the caller domain, and then the caller domain can do its thing, right? Which just returns the original value. And so what I think of it, like when I first kind of convinced myself that why tagless final is like clever, is there's no reason to stay in that caller domain. Why don't you just assume that what if you know something about the A? What if you know the algebra of the A? What if you, in fact, define the algebra of the system of the values A, such that you have a guarantee on the operations of A in a way, like in some sense. And the real like expression of this is like, what? Okay, like if you don't buy anything I've just said, I can show you like the quick and easy of it is, here is the trait expert A, that's just like a label with a type parameter, and then a bunch of case classes for the grammar, and then this is like the semantics, right? And here, all we did was add, we have the exact same label, and then we just added a value A internal to it. So we say we know something about this we're saying we just have a requirement that this algebra can like instantiate the value internal to itself. I guess I'm sure there's a name for that property. And then you just define just like before, you define all your other ones. But most importantly, when they return a value here, it's returning a thing wrapped in the original expert. So it's not returning an A like was happening in this. Oh no, this is returning an expert. I'm sorry. It's that you define your. It's not there. My bad. It's this one. This is the important part. This is the exact same. This is the important part. Is that you get to define your service without having to call into the function again. So you use the value directly, because you assumed you have some knowledge of like the A type of the algebra of A. And in this algebra, I just have access to the value A.
And Wouldn't you get that from the types that are in the OR function definition? Because Boolean is explicitly in there.
The type, yes. I mean, you get the same type safety guarantees that you got from the tagless initial embedding. Yes. So like the same like correctness by construction or like compile time guarantees are like they apply in the exact same manner. The only real difference is that you defined your like implementation of these operations inside the domain. Like you already know how you want Booleans to interact. You didn't need to like pull the Booleans into your domain and then
No casts, basically.
Yeah, exactly. You know, you can just like step into the expression domain. You know the algebra of that domain, and that it lets you do this. And again, maybe I'm like mischaracterizing. It's not exactly this. This is just my hand wavy attempt to.
So just my observation as someone who's not a Scala expert by any definition, it also seems like this would have the side effect of making it extremely easy to add additional implementations or additional functions on top. You know, if you wanted to add an XOR or whatever, that would be quite straightforward. Is that correct?
I think so. I'd love to hear. I mean,
yeah,
Sean.
That would be extremely.
Sorry, go ahead.
Extremely easy. That would be extremely easy. So you just add a new function there with your XOR, and the good thing is that you don't need to modify what you previously had. So it's just an addition.
Mm-hmm.
Yep, it's just a new interpretation.
So you generally just would have to add especially if you're just adding a new like operator like that.
Mm-hmm.
It'd be super easy because you just add that. Yeah, you add one more line to the algebra, and then you just have to add new.
Yeah, if you wanted to add a product, for example, you just add one line in the algebra, one line in the implementation, and then done.
Yeah, and you can even add, like what's also really nice about this is you can add additional types, right? I can add additional like support for additional primitives, because these services are all already like, strictly defined to the previous types.
Okay, so if let's say I wanted to add support for floats, for example. So I would need to add def-f with the types necessary for floats. And then I would need to add a new line for def-sum with floats instead of ints in that part. And then in the implementation, I would just need to basically copy the sum of the sum implementation for int and just change the types to float, and then I'd be done.
Yeah, I mean, let's do it. Scala. And Daniel for writing such good code. And I'm
This is Scala 3.
Yeah.
You can put yes, implicit. Yeah. I think it's just a current parameter that you need to add. The implicit val simple algebra should get a current. Like instead, like at the beginning of line 145, add a parenthesis or 1A14.
No, I'm sorry. I was on the wrong one. It took me to the. I didn't mean to be on the one I was on a second ago. This is the one I want to look at, because this is my other work. It's just complaining to me because I had this thing twice. Because I use this as I use this as my template because I realized that basically this is the this is the semantics, I'm sorry, this is the grammar, this is the semantics. Like, it's as easy as that. That's your language right there. This is your grammar.
Yes.
That's your semantics. But let's just do. At least I think that is what the realization I've come to. So yeah, to Hans's point, let's say we want to do def f float. Is it float or double?
Double.
Double?
I always use double.
You want to do
doubles?
Let's do double. Let's do doubles. That's fine. E. All right. Well.
And then we also need to add a new sum, right?
But I mean,
you're going to do it that way. Okay.
I mean,
yeah.
Well, what I'm saying is
fine ordering.
Like, yes, we do. What I wanted to do was I'm sorry. Yes, you're right. We will want to add a new thing. But what I wanted to point out was, like, I don't technically have to. If that makes any sense.
Simple expression.
Simple expression, yes.
Why are you complaining?
Okay, so in this, now that we've made this change, we could create an expression that contains a double, but we wouldn't be able to do anything else.
Yep, that's what
we don't have any. We don't have any operators.
Wait, why is it telling me to override nothing though? It's right there. Double. Oh, E double. Oh no.
I don't see anything wrong.
Yeah, I'm incredibly.
Me neither.
Why it's like telling me not to do that. Okay. Yeah, but yeah, let's go ahead and make your thing.
I feel better because I feel like if that happened to me while I was like learning or doing the tutorial or whatever, I would be like, oh no, I didn't understand the lesson well.
No, yeah, I'm really confused because okay, like maybe it doesn't like.
Yes, but something is there in the line 8. You see, you have an icon over there in each one, but not in line 8. I'm not sure why.
That little like function with the down arrow in the gutter on the left.
What do you?
Oh yeah, right there
yes.
in the gutter.
Oh.
Yes, in line 7 you have next to the number.
See how there's like a little green F with a blue arrow pointing downward? What is that?
This thing, I don't think this is anything. I don't think this is anything.
How come they all have it except for that one?
Yes.
I mean,
like
it recognizes their functions or something. I don't know.
I know, but it's got to be related.
All right. Well, look, maybe it's just like D0. It doesn't like the word. It doesn't like the word D.
Yeah, maybe is D a keyword? No.
No.
Okay. Well, I'm confused.
Oh,
now
it did it.
Now it's there. You see, now it works.
I realized it. Jesus Christ. Oh, whatever. All right. Whatever. We're moving on with our lives. Def.
The compiler just wanted to give you a few extra gray hairs.
I'm actually starting to get gray hairs in my beard. It's I realized, and I'm honestly digging it. I'm down for the gray hairs.
His gray hair is the compiler errors, and white hair in the head is runtime errors.
I can even do this, right? Like a value, and then whatever. We're just gonna do value. Maybe.
Right and left.
I'm sorry. I was trying to be fancy. I'm sorry. I realized I'm don't be fancy.
edible. I'll see myself out now.
Actually, I'm sorry. I'm gonna freak everyone out for a second. Here, do you want to see the craziest? I love this camera angle. I'm sorry, everyone on the stream, but we'll be back in a second. But here we go. No? Oh, when we're like this, it's actually looks normal. Never mind. It's the when there's only 3 people and you go to the the really skinny video thing, it just zoomed in on all of our faces and it was like a perfect like view like this of Brad and Mundo and I. And I really it gave me a really hearty chuckle. I'm sorry we couldn't experience it here.
I can't quite visualize it. I'm kind of imagining the face popping through the door in The Shining.
Yes, exactly like that. Exactly like that.
Too far off. Brad got a pretty crazy glint in his eye all of a sudden. I'm joking about that. I'm joking. Brad did not get a crazy glint in his eye. Please don't anyone. No worries. He's a very nice gentleman. It's not E, is it? It's simple expert. Now we have to find our we're gonna make another little learning example though. B, this is B, and this is simple expert of Google. And then I'm gonna say that it's mults, but the best part is that when you get to do whatever you want, because you have left dot, you have A dot value times B dot value times 100 and whatever, right?
Put an L at the end, otherwise it won't work.
Thank you.
Or make it a shorter.
And then I need to. Oh wait, no, it's gonna just turn into a double. Why can't you just turn into a double? Come on, Scala. I really can't. I can't do that to it. Why? I'm trying to
make it smaller.
Yes, put that. Yes, put that dot.
Some digits.
Sorry.
Yes, put that dot 1.0, and that should become a double.
Dot 0. That's how you can do that.
No, I mean it's like a comma.
Oh.
No, that's not zero. Not the method call, but just a number with a decimal.
There's no really surprising implementations like this in the code base, right?
Not as far as I know. Wait, how is this not? That's a double. That's a double. This is a value A. Well, that's gonna be a double. Okay, we're just gonna do 34. Smaller double.
34.
What is that? What if it's an int?
Oh, yes.
I think if you do a lowercase d after 34.
Yes. That's.
Yeah.
But see, now I've lost all my confidence in the compiler from before.
Yeah.
I have no idea if it's not working because we made a mistake or because the compiler is going to take a while to figure out what's going on.
Well, we can't see it's done processing. I don't know what's going on here. Scala.
What happens if
that
was
the bug they fixed in the update you didn't install?
Yeah. I'm trying to get rid of all the errors I have in this thing. Oh my goodness. Jeez. That help? Yeah. Sorry, it was my errors in there. My IntelliJ does that every now and then. It gets a little bored. Okay, I do realize we're at about the halfway point. Do we want to go around the horn maybe and just reintroduce and talk about what we're doing here? So I'll start. James, obviously the CTO over here at Topple. Today we're talking about our extended UTXO smart contract system called Quivr, and how we are going about building it and learning from the examples of tagless final for trying to build an expressive yet well-constrained and robust model to let users express their domain logic. Sean, you want to go next?
Yeah, I'm Sean. I'm a blockchain engineer here at Topple. I write the code for our fancy little Bifrost thingamabob. It makes blocks. It includes transactions in those blocks, and that's what I write the code for. It's based off of the awesome research. We're joined here by Hans. I'll let him introduce himself in a second, but I'm writing the code for the awesome research team that for the awesome work that the research team has put together. Yeah, I'll popcorn over to Hans then.
Thank you, Sean. What a glowing recommendation that was. I'm Hans. I'm one of the researchers here at Topple. And mostly what we do is we try to find problems that are hard to solve and come up with ideas to solve them. And then when we need someone with a little bit more skill at the keyboard than we have, that's why we've got Sean and Edmundo here to help us take those ideas and sort of translate them into reality. Edmundo, why don't you introduce yourself?
Yes, I'm Edmundo. I'm also a blockchain engineer here at Topple. And yes, I think I do what Sean does in another code base.
Don't sell yourself short, man. This Edmundo wrote a whole DAML presentation thing in 7 weeks. He taught himself DAML, wrote the whole presentation and a whole application in 7 weeks. Edmundo, you're a brilliant man. Everyone on this call.
The recording was really crisp too that you did for that talk.
Right, it was great. I think it should be up on the YouTube channel either. I hope it's up.
If anyone's interested in understanding the basics of DAML, I highly recommend that you check that out because it's easy to follow and it really gives you a flavor of what DAML can do.
Very, very well done. And hopefully it's just the start of many more.
Yes.
Cool. All right. I'm gonna hop back. Whoops. Only one. There we go. Hop back to this. Okay. So I think we got our mult double now. So now we add a new type. We add a new service logic, and the point I was trying to make though is these really are this service logic in my mind is I say that these are the semantics because it is it's the constraints of the system because you're really defining the service level. If you put in some random lower limit or something as a semantic, as a hard-coded semantic, or as an environmental constraint, right? It would be at this level, not, or you'd probably want to do it at this level unless you're trying to do it at the unless you want to actually constrain your algebra overall. But that's I'm sorry. I guess the reason let me rephrase. The reason my mind jumps there is to say I want to have my algebra and then have this distinct is because I'm thinking about having multiple of the VMs, but I'm realizing as I just said what I said that I didn't like the way I said it. So maybe I'll restructure that. I think it's probably useful to say that you have this is a constant construction, and then you can put this in another construction. You can put another one of these inside a construction like this that lets you do the additional value thing. Anyway, don't worry.
I think a good example of this was what was it continued fractions versus Lenz's method?
Mm-hmm.
Two different ways of interpreting the symbol exp, the exponent base natural whatever math thingy. I'll let the smart people explain that one, but yeah, it's just two different ways to do it. One's faster but less accurate, and or something like that. But Yeah. So we only have one interpretation in there. We got rid of continued fractions, I think, but yeah, it's just we found a different way to interpret it that led to more accuracy.
Oh, but even an even easier one though is like, or maybe easier is like your or I was thinking your storage interpreters.
Oh, yep. So the algebra would be defined up in the algebras module, but one of the interpreters would be in the level DB module.
Right. Yeah. So this is the, for a generic, I guess, would you call this a generic store, like the most generic kind of key value store, or
Yep.
an effectful, or I don't know, would you call this effectful? What do you?
Yeah, that's the F context that everything runs in and is returned in.
Right. I didn't know if that was enough to say that this is like an effectful key value reader, or right, and then so then we can write a. So when I say effectful, I just mean like Sean said, you can think of this F as like it's a side effecting thing. It can be a future, or it can be an IO, or something like that, right? It can have impure. You can have side effects. So yeah, so this could be the algebra, and then the most important part, though, like Sean was saying, is so a level DB interpreter for this would be here. We're returning a store of these key values, and then we actually realize this using this, or Sean realized it using this level DB. Right here, use DB, and use DB is coming from something else. I don't know. Oh, use DB is here. Oh, I see that you're wrapping it in a. So it defers, like you wrap it in the sync F, so it's going to block subsequent ones. But is the sync wrapper, does it only force sequentiality, or is it also like defer computation until call time?
So there's that would be more like sync.defer or sync.delay. The sync.blocking is just saying run this computation on the block or the thread pool meant for blocking operations.
Oh, I see. Okay, yeah.
It's not enforcing like any sequentiality or anything like that. It's just saying run this on the dedicated thread pool.
I see. Is stuff? Does it result in sequential because of that, or can you have? Are there multiple threads in that blocking thread pool? So like,
you could have. It's like by default, I think it's going to be up to 16.
I see.
Threads, and yeah, so like if 5 different threads all try to call the get method here, like they could all happen in parallel.
Right.
It's not defining any ordering. There's no semaphore to lock other threads out, for example.
Right. Oof, semaphores, man. This whole effectful, it's rough. I'm so glad you're good at it, Sean, because
so I just want to make one other note about like the interpretation of that store we were looking at.
Yeah.
This interpretation constrains the key and the value by saying that they need to have instances of this persistable type class in scope. And so that's not a requirement on the underlying algebra. The algebra doesn't really care. It just says these are the 2 types. But for level DB, those 2 types both need to be like persistable to the disk. They need to be serializable, in other words. So like you can just interpret things in different ways, but still all share the same underlying store. And it's different from like the cache store, for example, which is another interpretation of store, or the ref store, which is another interpretation of store. And so they all have like slightly different requirements and constraints and whatnot.
Or the
Yep.
Yeah, or the in-memory secure store.
That's a different algebra, but yeah.
Well, does
do
your
have
secure store build off of the normal store though?
No, they are entirely separate, but there are two different interpretations of secure store.
Yeah,
So I think you just pulled up in memory, but then up at the top is ACA secure store.
Yeah, I see. Okay. I thought that you would put a wrapper in front of the normal store. I see now though.
Oh, got you.
Yeah, one more thing that when Sean mentioned that though in the in secure store, not secure store, where were we just key value store? Where am I? Lovely. Oh, here. This actually one. Just like a really easy way to define a different. What Sean didn't, I'm sure he did. It's a bit much to go into what persistable and what these things are. But basically, by putting this colon here, we know that this method, we're able to call this method, right? This syntax right here is what lets us do this thing, what lets us call this method. Just like, and for the same reason, like this one here lets us call it on the T, right? And that's just like it's a Scala syntax thing, right? It's just like a sugar that Scala chooses. But what I want to point out is that like persisted bytes is just an ordering of the bytes, right? We could do a different ordering of the bytes, and that would be an entirely different interpretation, right? So it's not just that you have to change the underlying like mechanics. It can be any like setup parameter of the interpreter. Like if you change it, that's a different interpreter.
Like when I tried to do like a network store, use the peer-to-peer layer. And I interpret a store using the peer-to-peer layer, so it's using like the transmittable basically instead of persistable, for example. So it's just different ways to interpret.
Yeah, exactly.
That plan didn't work out. Well, I mean, it might still, but it didn't work out at that moment, so I kind of abandoned it.
There's a video on YouTube of like that estimates how performant a blockchain hard drive could be. I wonder if you want to try and see if we can compete with the metrics in the video. Actually make a viable blockchain hard drive.
Like a file system?
Yeah, I don't think it's a good idea. I'm not. I think it's a reasonable idea to like explore these like small groups. I'm really just joking over large systems.
I think it's a great idea.
Yeah, I would love to actually think through more like storage or bulk like data availability and storage like integrations. That would be super, and especially like, if we could start to shard data and like automate the sharing between participants. That'd be super cool. Especially with this whole idea of like the bulk storage as a service. If we can enable that with the extended UTXOs. Oh, baby. Anyway, let's see. That's pretty much it for this. He does kind of go into the last little bit to say, right, this is just a really clean way to describe it. But we normally, whenever a tagless final is introduced, like pretty much, at least back a little over a year ago when we were starting to try to learn this, I had never seen anyone like saying that this was a way of this was tagless final. It was always introduced with this F, with the whole F hole, like the higher kind of types, and that kind of makes it a little more complicated, in my opinion. Because if you wait to introduce the higher kind of type at the end, you remember all you're doing in the tagless final thing is saying I'm gonna assume some algebra on this like internal state. I'm gonna assume some structure this thing such that I can act on this value directly. I can build my algebra and the semantics of my algebra. I'm sorry, the grammar of my algebra by using like the known properties of this value within the scope. So I can use the values directly. So yeah, if you just do that with a hole here, well then you can make it super easy to. You just have to return the same E out here, and then it's still just as easy to add a new type because you could just do the same thing of adding an int like we did. You can add the XOR like here, and that's pretty much it, right? You have and then what I really love is that, so this is the final kind of altogether V2 thing. So this is your, again, like your, I think that again, someone told me about it, or please let me know if this is mischaracterization, but like, grammar and semantics, and these are your programs, just like Edmundo said. And then, if I just change some labels, now I got a Web 2.0 system. Now I have an API.
Okay, I have a question.
Mm-hmm.
Can you go up a little bit?
Mm-hmm.
Okay, so here under this program 1, or program 2 for that matter, where they're actually exercising this definition that they've created,
Mm-hmm.
Is there functionality in Scala to overload operators like there would be in like C, for example, where instead of writing it in this way, in this sort of functional nested way, you could do it using actual operators themselves?
You can define. I'd have to let Sean, or I'm sure Sean could show some funny things, but yes, you can define your like Scala is actually really, really expressive in terms of what can be a function name.
Okay.
Like a string can be a function name. Like you can actually have like strings as variable and function names. So any string literal can be a name, a variable name. So yeah, we could if we could draw the Unicode, like if we had keyboards that could draw the set theory things, guess we could make those our and or in the code if we wanted, right?
Yeah, and Unicode characters can be function names also. So
Yeah.
you could technically have that symbol there. Technically, don't do that, but you can do
it. There are some limitations. You can do whatever you want as long as you wrap it in backticks as a name.
Yeah. It's true.
But like, for example, you can't have something that starts with a number.
Yeah, it doesn't like that.
Yes.
So, yeah.
It also doesn't like periods in your names for some reason. Dang parsers. And they're special characters.
At least it's not like, I can't believe Swift did it. Swift, like the programming language, they allow emojis as variable names. Come on.
I think you can do emojis in Scala also.
Yeah, I thought you could. I think you can use emojis in Scala.
I think you can do it.
Like it with the backticks, yeah. But I don't think they're allowed.
Normal character. I'm not sure. Yeah.
I might be wrong. I don't know. I didn't think they were allowed as just regular.
Oh, excuse me. Yeah. Well, I don't know. We've been going for a little bit. I know, Hans, you had to drop 8:30.
Yes, I'm going to need to drop off here in a minute or two.
Yeah.
But thank you for having me and entertaining my Scala noob questions.
Thank you for joining us.
And thank you to the viewers. I know that I didn't see you guys all the way from the beginning, but we're glad you're here. Probably you'll see my face again before too long.
I hope so, Hans.
Okay. Bye, everyone.
Everybody, have a good night.
Bye, Hans.
Bye.
Okay. Well, so maybe I don't know. Unless we don't have to go for another half hour, but we can maybe. I just want to share. Look, I started going through So Rick, I'm sorry, Sean, you
We're just
made.
gonna do a few minutes of Quivr. Don't worry.
What's that?
We're just gonna do a few minutes on Quivr here.
Yeah, we'll finish. I promise. I mean, we're not gonna go past 5 at least. So this morning when we were talking about this, you kind of made me realize that, like, I don't think this is the right. Like, it's very close to our description, but maybe I'm just gonna embrace actually trying to do our description and not like shoehorn it into some other process just because it's in a book, right? Because what I've learned about these processes is they just make them up, and the labeling is inconsistent and whatever. I'm just gonna write it down this way, and people can tell me if I'm wrong or why it's split up a certain way. But I'm pretty sure I just gotta write it down a way. So I'm not gonna, I'm willing to be told I'm wrong. So there we go. Our description, though, I think in this like non-interactive process is you could like generate your secret X, so like your SK. You could generate your commitment to that secret, like your VK. And then I moved the generate R and the generate U up to this point because I'm actually thinking like that's what a like. So if I write a contract, like let's imagine I just don't have those 2 points. I don't have those 2 steps. Let's just get rid of them for a second, right? So now I only have an X and an H, right? And that X and that H could be, for instance, X equals SK and H equals a VK, right? And VK, SK and VK are like a pair, right? So X and H are just, I'm relabeling, right? And then we go, because I don't have the other 2 steps, I say compute verify proposition, right? So the proposition is just G triple prime of U and H, but I don't have U, so it's only G triple prime of U. I'm sorry, G triple prime of H, which means that G triple prime is just our proposal function. It's just our challenge function, or like our proposer function. It's basically just the H becomes what H is are the input arguments needed to create that proposition, right? Those what I was calling this morning like the challenge constructor arguments. Like I think that's what H we could equivalently call it because that's what a VK would be. And then we say, okay, so I'm going to instead of following again, I'm breaking from the Sigma protocol, right? But I do kind of think it's equivalent. We're going to say commit to proposition P as E of H of C. So take the hash of the contract, just like H was the hash of X. Or okay, I'm sorry. I know I'm saying it's the hash of this. I'm saying it's what I really mean to say is it's a linked thing. I know this doesn't actually work when it's a signature. I was trying to do this in a more generic form, so maybe I'm still struggling on that part. But yeah, here I do mean you take you create the digest of the hash of it, and then you publish this. So this would be like when you encumber your tokens, right? So there's another step here that I'm not showing that actually is the transaction itself. This challenge would get included into the contract, and the contract is what gets put on the on chain. What gets committed to on chain. But I'm trying to say this challenge is the combination of the evidence of the proposition and the state. I just called it challenge. I'm not like wedded to the name. I just think like a proposition is a challenge. It's just to me, it's like a synonymous word for proposition. Does this make sense? Or like so far, maybe
the state of what?
The state. Oh, like the token state, like the box state. Like it's a state completely
okay, I see.
It's completely separate from like everything we've talked about so far. It's just like it's like a hanger-on, right? And it doesn't actually matter until actually way down here. Validate.
So the S would be the box, and the E would be the
well, the S would be the box value, And
the
then
box value, yes.
Exactly. Yeah, exactly. E is the evidence and S is the box value. So I guess you could equivalently, I mean, yeah, I don't want to call this a UTXO because I think it is a single UTXO, but output is a list of UTXOs, right? So I guess you could also just call this UTXO.
HLC.
I don't actually know that. I'm still trying to figure out my labels here. But it's good labels. I just want to say that this is when you like lock tokens up under that contract.
Yes, but normally shouldn't it be the h of x that you put there with the s?
But I wanted to I don't want to I want to hide it behind this, like, because okay, the big change from this other one is, remember when I was talking to Sean, I got confused because I was like, man, I can't square. How do you deal with this part? Because this like contract thing, it reminds, like, the thing you're doing here where you're checking that the contract that you get is the same as the contract they should have calculated. This feels more reminiscent of like checking the hashes of the evidence than it does anything we do internal to like the math that you do in the in a normal like Schnorr or like the description of the Sigma protocol, right? Like where you have this like math, this arithmetic that supports those sorts of operations. So if I can't say I have something like this, then the thing I have is evidence of, like, I have a commitment, like here, that's what I'm saying, is like my commitment, my evidence to the contract, to the code is this E, but I'm hiding,
You want to hide it behind some digest.
Right, yeah, so E obfuscates the proposition, and then the proposition, to create the proof, I have to supply H, but I can supply H without revealing X, which is the most important part, right? Assuming that this isn't H like this. I'm sorry. Let me just, in this example that we're doing right now, it's X dot VK.
Okay. Verify proposition P. So what is missing here is, where do you get the C from?
Where there is no, the C is this P. There, I don't have a C. Oh, I'm sorry.
Yes,
You're right.
E digest.
I forgot to change this letter. My apologies.
Yes, you have it up also.
Oh, I do. Yeah.
This T1 is also the H of.
I'm sorry, my mistake. I had C originally, and then I changed my. I was trying to change my notation.
Okay.
Thank you for. So many of them. Jeez, how did I like? Ugh. It's confused. So many people. They're like, you're talking about just all and you got your C's and P's and.
So H of P. The proposition comes from the G triple prime.
Yes.
Okay, the G triple prime was the oracle, the random oracle or the hash function.
Exactly. So all I'm saying is that you can. So you have a way to serialize VK, and then you have you're hashing VK, right? And really, well, that's to do E. This part we don't have to think as a random oracle. This doesn't have to be a random oracle. This is just this. Like it's just a. I'm sorry. Let me show you it. So that, yeah. Here we go. It's just this, right? Because all I'm doing, all I'm trying to do here is compute the verify proposition, like compute the agreed upon thing that. So here, remember I said that the challenge validate the given proposition. Right, to validate the given proposition is the expected. So you validate the given proposition is the expected one. It's actually not P equals P prime. It's E equals E prime, which comes from the hash of G triple prime of U H. But remember, U, we don't have U in our little example here. Oh my god. This is like the worst little thing to follow.
And now you, okay, H is BK. Type BK.
And then I actually hadn't figured this one out yet. I don't know what this. Yeah, so this is, I'm just saying that the proposition, the challenge, the encumbrance to the box, the script on the box, like that's what, like this is or you can just simply UTXO, right? This is and it has the evidence of the contract and the script and the state, the box.value, the state of it. And then in the second transaction, you can just compute your proof as G prime, which is just the proof function, right? Like what, and when I say it's just the proof function, what I'm saying is like, what is G triple prime? What is G prime? And what is G prime, G double prime, and G triple prime are the three parts of the signal protocol. G prime is the how you generate the proposition. G double prime, I know G double prime is down here, so like it's used down here solely enough. But G double prime is the verify function. G triple prime is the proof generation function.
Okay.
So I mean that's what these G's are. They're not I changed little g, the one without the primes. That was a hash function. I changed. That's why I changed to big H. So big H is, I'm saying specifically a hash. You've been very. Is this? Do you think I'm overcomplicating things, Sean?
No, I don't think so. I think like using the terms that, well, I'm familiar with at least is helping me. Like using the word proposition, proof, secret, verification key. Yeah, I'm just observing.
Yeah, honestly, as I look at this more, we might just be able to call this a UTXO and an STXO. And I think I might need to do that because the problem I'm coming across is that I want to validate the state mutation in the context of the outputs of the entire outputs of the transaction. Actually in the context of the entire transaction, like the inputs and the outputs. And I don't know how to express that in this thing without knowing that.
You're not mutating state, you are transforming it.
I'm sorry, say one more time.
You are not mutating the state, you are just transforming.
I'm sorry,
so
yeah, I've never
generating a new state from the old.
Right, well, and more so, we're not even generating the new state because the transaction itself tells me the state. I'm just, when I say I'm mutating, I do think I am mutating because I'm taking the inputs and I'm mutating them to get to the outputs, and then I'm checking. I'm checking. Do the outputs that I get match the outputs that they got? And then if it does, then I let it go. Or do the outputs that I get, if I guess you want them to match. Yeah, I guess you'd want them to match if you know. That way you know that the arithmetic has been followed or is valid. But I just don't know how to, I think to express that, I think I need to know about the structure of the transaction, which I was trying to avoid pulling into this because I was trying to, yeah, I thought it was overcomplicated. Like here, I'll show you. It was in the code. I had all this stuff. I was doing this before, but you see, I was ended up doing the classic thing that I did in Dion. And one, Sean, I'm very. This is probably the grossest like way to do this. I'm just trying to get something that could work, that then you guys like we could potentially make more elegant or more streamlined, more ergonomic. But I find myself doing the same thing I was doing in Dion, where I was like over type parameterizing things. And so I realized I was like hanging that around, and I was like, oh, you know, the only place I used transaction was like here. And could I just replace that with a single M and not have to worry about all these other things? And I don't know, it was working up to a point. I get stuck on this part though. I basically come to the realization, like here's where I got stuck. This is like the last point I'll end on, is just kind of like in the auth, the normal like process of validation. Sean, you had identified that there's like syntax, semantic, and then authorization. And like very similar, or like not very similar to that, but like I think there's like similarly several steps that I can think of, and it's essentially these three that we looked at here, right? Validate that the contract or the proposition that was given matches the evidence, like you get the same evidence that was previously committed to. Validate that the proof given satisfies that proposition. So does the proof satisfy the proposition? And then is the state that they're claiming a valid output state for the like protocol that they're trying to execute, or like within the scope of the protocol they're trying to execute. Like, I'm sorry, within the scope of the ledger that they're trying to execute in, like using a particular schema of state and a particular instance of those like values of those variables. And that's basically what I just wrote up here, because I'm trying to, those three functions are pretty much propose, prove, and verify are the three different pieces, I think. And I'm trying to break up verify to try to let these parts be automated if you can do these two, which just means you need to be able to do this and this and this. But then could I just make it to where the user has to define the like actual service logic of the predicate that is the verification that has to happen? Like in a height lock, the verification has to be, you know, greater than the number, right? So that's like what I'm saying is like that like service level logic predicate or logical predicate. So I just want to break off that predicate part, so that the user just has to find that what the proof, basically what the proof constructor arguments are and what the proposed constructor arguments are. And that feels like the only things that you'd ever need to do to create a new instance of a Sigma protocol. And yeah, that's what I was working on, or that's as far as I've gotten so far, at least. But yeah, that was a lot. It was long. It was a long-winded. Man, one of these days, I think I'm just gonna I'm gonna wake up and my voice isn't gonna work, and I'm gonna wonder why, and I'll know why. I should know why. Here you go. Wait.
I don't know how you do 2 hours. Like, I'm exhausted after one. Like if I have to talk the whole time.
Yeah. Well, no, thank you guys. Though it is much easier when there's like people to talk to, or it flows. It's man, one of the hardest things ever is like presenting to just a blank screen when you don't know. There's no feedback.
I just assume that everyone loves what I'm saying.
Yeah, of course.
Every time.
Alrighty. Well, any last thoughts or questions from the audience, or things you guys want to maybe bring up, or things we could do for next time potentially?
Just We're giving people very flexible levels of security on our blockchain. Securing their, well, yeah, I guess more secure than stuffing your dollar bills under the mattress, but we're giving people options, you know? Gotta protect your stuff.
Trust is a spectrum, for sure. Alrighty. Well, I'm gonna go ahead and do like throw up the socials, and then you guys can stick around for just a second. Oh my god, my computer is freaking out, guys. It is like not liking something. I'm like stuttering all over the place. And all right, here we go. All right, folks. Well, thank you all for joining us today. You know, if you are intrigued or interested and want to find out more, please definitely feel free to check out our link tree at linktr.ee/top_protocol. You can find all of our socials, Discord, Twitter, LinkedIn, GitHub, Twitch, as well as our YouTube channel, links to our website, topple.co. We also have job postings, which we're still hiring, and you know, any questions you might have about anything, any of the real amazing work we're doing, we're more than happy to engage and learn and teach and find new experiences. And so if you think you have a good idea, we also have like a grants program that we're running at the moment, as well as like a CFP that we're involved with for ACSAC 2022 here in Austin in December, and lots of other exciting stuff on the horizon. So stay tuned for more info, more learning sessions from us. Hope to see you all back here. Again, thank you to Edmundo, Sean, and Hans, and everyone else for tuning in, especially to the folks who are here with me to help me run the broadcast. And I hope everyone has a great evening, and we'll catch y'all next time. All righty. Have a good one, everyone.
Thanks, y'all.